Hello, and welcome back to Math 050. This is a video over 9.1, and this is going to be a section about graphs and applications of linear functions. So what we're going to be able to do today, we're going to plot points on a Cartesian plane. We're going to be able to find those points and identify what those points are on a graph. We're going to be able to determine whether an ordered pair is a solution to an equation, and then we're going to start graphing linear equations in the form of y equals mx plus b, which is slope-intercept form, and then ax plus by equals c, that's going to be standard form, and then we're going to be able to identify the y-intercept from that. So let's go ahead and let's just talk about points on the Cartesian plane. So let's just go ahead. What I want to do is take a look at these points here. Okay. Now, whenever I have a point on a graph, we always call this the point x comma y. So the first number, okay, in any point is always your x value, okay? And then the second value in this point is going to be your y value. All right, and so we have this thing over here called the Cartesian plane, all right? And what we have, this is just a, basically a flat surface where we can locate certain parts of a graph, okay? And so basically, a point is just a location on the graph. And I want to write that down up here, that a point, okay, a point is a location on a graph, okay? And the practical application of this would be something to the effect of like longitude and latitude points on a globe, okay? It's kind of used the same way. So, but on this Cartesian plane, what I want to do is talk about the 4 different quadrants. Now we have our first quadrant here, all right, which is right here, and that's when my x value is positive and my y value is also positive, okay? And as we move counterclockwise, this is going to be the second quadrant, okay? And this is when the x value is negative, but the y value is positive. Over here, this is going to be my third quadrant, and that's when both my x value is negative and my y value is negative. And then over here, we've got the fourth quadrant, and that's when x is positive, but y is negative, okay? And so what we're going to do is we're going to take all these points here, and we're going to graph them, okay? And what I do when I take a look at, like, say, the point 4, 5, okay, what I know is that my x value is 4, okay? And so x value is 4. And what I'm going to do is I'm going to count over. I'm going to always start at the origin, okay? And I'm going to count over 1, 2, 3, 4. And then my y value is 5. And so from the origin, I count up 5. And I go 1, 2, 3, 4, 5. And I find the point where those two meet, which is the point right here. Okay, and that's the point 4, 5. Okay, now if I were to try and look at, say, the point 5, 4, okay, what I would do is, and you don't have to always do this, okay, how I do this, I usually go over 5, so I go over 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. And that's my point here, and that's going to be the point 5, 4. Now, having the point, say, negative 2, positive 5, okay, what I would do is I would go, since x is negative, I'm going to go this way on the negative. I'm going to go negative 1, negative 2, and then up 5. 1, 2, 3, 4, 5. And I'm going to plot a point there, negative 2, 5. Okay. On the next one, I've got the point negative 3, negative 4. All right, so I'm going to go to the left 3, so 1, 2, 3, and then down 4. 1, 2, 3, 4. All right, I'm going to plot my point there. Okay. On the next one, we've got the point 5, negative 3. Okay, and so I'm going to go over 5. So I'm going to start at my origin, go 1, 2, 3, 4, 5, go down 3, 1, 2, 3. And I'm going to pop my point right here. Okay, the next point I have is the point negative 2, negative 1, and so I'm going to start here at the origin, go down left 2, and then down 1, and that's going to give me my point there. Okay, if I were to plot the point, say 0, -3, what I would do is I would start at 0, okay, and I don't go anywhere because my x value is 0. I don't go to the right and I don't go to the left. And so I would just go down 3 units, okay, and plot my point. Okay, if I had the point 2, 0, then that means that I would move 2 units to the right on my x-axis, and I wouldn't go anywhere on my y-axis because my y value is 0, okay? And so basically, you know, what I want you guys to think about here, when you have a Cartesian plane, you know, all you have is an x, like a horizontal number line and a vertical number line, okay? And so if you plot those points on the x number line and the y number line, and then you find where they cross, it's kind of one of the ways you can think about that, okay? So that's, you know, what I'm doing in a nutshell, okay? And I do want to say that, you know, over here that these are positive x values, these are positive y values, negative x, negative y. Okay, so that's kind of how you want to look at that. So hopefully that's a good refresher for you if you haven't seen this in a while, and we'll go from there. All right, so now, you know, on this next example, what they want us to do, they want us to find the coordinates of points A, B, C, D, E, F, and G. Okay, so we see those points here. All right, and so what we want to do, not only be able to take a point, all right, like we did here, and be able to plot it, but we want to be able to look at a graph and know what those points are, okay? And so, you know, let's just start with point A, okay? In point A, what I notice is that if we start at the origin, that's to the left 3 and up 5. So this would be the point -3, +5. Okay, for point B, all right, that means we're going to go over 5 and up 1. Okay, so that means we're going to have the point 5, 1. All right, for point C, it means we're going to go to the left 4 and then down -3. Okay, so C is the point -4, -3. Okay, and then point D is the point 2, -4. Okay, so D is the point 2, -4. The next one is point F. All right, and so that means that we're going to go to the left 2, and we don't go anywhere on up or down, so my y value is going to be 0. So this is going to be the point -2, 0. The point, oh, I forgot point E. This is why I'm a math teacher. The alphabet is, I struggle with it. So, okay, so if we start at 0 and we go to the right 1 and then up 5. Okay, so that means we're going to go have the point 1, 5. All right, and so the last one we've got is point G. Okay, in G, we don't go anywhere on the x-axis, but we do go 3 units up from there. So that's going to be the point 0, 3. All right, so not too terrible. Hopefully this is a good refresher for you. But again, remember that all these points contain an x value as their first number, and then the y value as their second number, okay? And we're going to talk about why we need that, okay? So, you know, what we're going to do is we're going to be talking about an equation involving 2 variables, okay? And what we want to do is talk about whether or not these points are solutions to an equation. So solutions to an equation are numbers that make equation true. Okay? And we're going to talk about that here in a second. So what we have here is we have, you know, we want to determine whether each of the following pairs is a solution to the equation 4q minus 3p equals 22. Okay, so what I had talked about here was that, you know, typically you have your solutions come in x, y form, or your points come in x, y form when you have points like this. However, we're dealing with a couple different variables, okay? So the variables, when we're talking about this, the order in a coordinate point all right, goes in alphabetical order, okay? And what I mean by that is this. If we have the points P and Q, all right, then I would have this, the point P, and then Q would go second, because this is first in the alphabet. All right, well, let me just write that this is before Q. Q in the alphabet. Okay, and that's how I know that. So what I noticed that here is that given that this equation, if we've got, say Q and P are our variables, and we're trying to determine whether or not these points are solutions to this equation, what I want to do is identify that this is the point P, and this is the point Q, and that this is the point P, and that this is the point Q. All right. So what I want to do is I want to determine if these following pairs of numbers are solutions to this equation. So what I'm going to do is I'm going to check to see whether 2, 7 is a solution here, and I'm just going to plug those numbers in. So if I write out my equation, let me zoom in here. 4Q minus 3P is equal to 22, and we've got the point 2, 7. What I know is this. I know that P in this point is equal to 2. And I know that the point Q is equal to 7. And what I'm going to do is I'm going to take these numbers, I'm going to plug them into this equation. So I've got 4 times 7 minus 3 times 2. And I want to know, is this going to be a solution to 22? Is this going to give me 22? So if I do 4 times 7, that's going to give me 28, minus 3 times 2, which is going to give me 6. And is this going to be 22? All right, and so, if I take 28 minus 6, okay, that is in fact going to give me 22, and 22 is equal to 22, and this is a true statement, okay? So, therefore, my answer would be 2, 7 is a solution, okay? Because if I plug it in and we get that number, and we get a true statement, then we have a solution. All right, the next one, let me do this for the other point. Let me rewrite this as 4Q minus 3P is equal to 22. And I want to check the point negative 1, 6. Okay, what I know is that P is equal to negative 1 and that Q is equal to positive 6. So if I plug those in, I'm going to get 4 times 6 minus 3 times negative 1. And do we get 22 out of this? So if I do 4 times 6, it's going to give me 24. And then negative 3 times negative 2 is actually going to give me a positive 3. And is that going to equal 22? So 24 plus 3 is going to give me 27, and that is a false statement. Okay, 27 is not the same thing as 22. So what I would say is that the point negative 1, 6 is not a solution. Okay? Okay, so what I want to do here is show you on this example here. It says show that the pairs 3, 7, 0, 1, and negative 3, negative 5 are solutions to this equation, and then graph the 3 points and use the graph to determine another pair that is a solution. So let's do this. I'm going to write down the equation y equals 2x plus 1. Okay, so y equals 2x plus 1. All right, so we've got x and y. This one's pretty easy to see. Okay, so I've got the points 3, 7, 0, 1, and negative 3, negative 5. So 3, 7, 0, 1, and negative 3, comma, negative 5. All right, so what I want to do is check to see if these are solutions first. All right, so in this first equation, I know that x is equal to 3 and that y is equal to 7. All right, so what I'm going to do is I'm going to check that here, and I'm going to say, okay, if I'm going to plug in 7 for y is equal to 2 times 3 and then plus 1. So 7 is equal to 2 times 3, which is 6, and then plus 1. 6 plus 1 is going to give me 7. So 7 equals 7. That means that this is good. We are a solution, okay? Let's try 0, 1. Let's let x equal 0. and let's let y equal 1. If I plug that in, we're going to get 1 is equal to 2 times 0 plus 1. 2 times 0 is just 0. So 1 is equal to 0 plus 1. I know that 0 plus 1 is just 1, so 1 is equal to 1. This is a solution. Okay, let's check out x equals negative 3 and y equals negative 5. Okay, so if I plug in negative 5 for y, I get 2 times negative 3 and then plus 1. So this is going to give me negative 5 is equal to 2 times negative 3 is negative 6 plus 1. Negative 6 plus 1 is just going to give me negative 5, and negative 5 is equal to negative 5. Okay, so this is also true. So all three of these are solutions to this equation. Now this equation, you know, what I want to talk about here is this is a relationship, okay, between x and y. All right, and that's what any equation really is. It's just a relationship between one side and the other. And so let's just plot these points real quick. Let's plot the points 3, 7. So I'm going to go over 1, 2, 3, and go up 7. 1, 2, 3, 4, 5, 6, 7 is my point. Plot that point there. I'm also going to plot the point 0, 1. All right, so I'm going to start at 0. Don't go anywhere here. I'm just going to go up 1, and that's going to be the point 0, 1. And then I'm going to plot the point negative 3, negative 5. Okay, so I'm going to go to the left 3, so 1, 2, 3, and then down 1, 2, 3, 4, 5. Okay, and that point's going to go right there. And so what I know about this is that all three of these points can be connected using a line. And that's what I mean by a relationship between x and y, all right? Because, and let's do that real quick. So if I connect these points here, okay, what I know is that I also have all of these other points on this graph. So I could find other solutions to this equation, okay? And let's just look at this point. Let's just look at this point, which is the point 1, 3. There's a bunch here. But let's just check to see if 1, 3 is a solution, okay? So if I check 1, 3, all right, I know that x is equal to 1 and y is equal to 3. If I plug it into my equation up here, I'm going to get 3 is equal to 2 times 1 and then plus 1. Okay, and all I'm doing is just plugging those numbers in. All right, so if I get 3 is equal to 2 times 1, that's just going to give me 2. And then add 1, and then 2 plus 1 is going to give me 3. 3 is equal to 3. Therefore, that's a solution. Okay? And so, you know, the difference between something like this, where you have a series of points that make an equation true, all right, like this, you know, they represent a line. And we're going to be talking about lines pretty much for the rest of this chapter. And so, you know, the thing that I want you guys to see is that this relationship up here doesn't have any sort of like equation to it. Okay, these are just a bunch of random points, same as these. Okay, but when you can connect them with a line, then that means that they form a relationship. Therefore, we have an equation. Okay, so we're going to explore that on the next page and go from there. Okay, on this page, what I want to do is we're going to graph some of these linear equations, and what we're going to do is I'm going to show you how to get some points in order to do that, and we're also going to identify the y-intercept. Now, the y-intercept, we're going to talk a lot about the intercepts. The y-intercept, that is where the line crosses the y-axis, okay? And x is always 0 at the y-intercept. Okay, so let's go ahead and let's take a look at this equation here, where we've just got y equals 2x. Okay, and what I'm going to do is this. I'm going to create a t-chart, all right, and I'm going to put x values and y values. Now, in order to do this, in order to like get some points, what I have to do is I have to choose numbers for x. Okay, I have to choose numbers for x. Okay, and typically the numbers that I choose are like really easy numbers to operate with. Typically what I do is I choose like -1, 0, and +1. Okay, and one of the reasons why I choose 0 is because it's such an easy number to operate with, but it's also going to give me my y-intercept, okay, which is what we want. All right, so the y-intercept occurs when x equals 0. All right, so what I'm going to do is this. I'm going to choose numbers for x, and when I choose those numbers, I plug those numbers into my equation, and I'm going to do y is equal to 2 times -1. And what I do, when I plug in -1 in for x, it's going to pop out a y value, and it's going to give me the value of -2, okay? And so I have -1, -2. All right, now I'm going to do the same thing for 0. I'm going to plug in 0 for x, see what we get for y. 2 times 0 is just going to give us 0. So I have the point 0, 0. And then if I plug in the number 1 in for x, 2 times 1, it's going to give me a value of 2. Okay, now, all of these points, when I have this t-chart written out, I'm going to rewrite it over here so you guys can kind of see it. X and y, I have the point -1, -2. I have the point 0, 0. And then the point 1, 2. Now, when I write them down in this table form, we must be able to translate that into a coordinate point. And I would have this as the point -1, comma 2. Sorry, -2. This would, you know, having those columns in there, those represent points. That's the point 0, 0. All right, and so then the values 1, comma 2. So let's go ahead and let's plot those points here. I'm going to do 0, 0, plot that at the origin. Okay, 1, 2, and then -1, -2. Okay, and if I collect these, you know, points here, all right, we get this line. All right, and I'm just going to draw it like so, and that's that. Okay, and so we get this line, and what we can do is we can identify that we have all these other points, okay, on this line, okay, and that's what we're, you know, trying to identify. But what I want you to identify is that this value here is your y-intercept, okay, so that's what we've got. All right, let's take a look at the next one. Next one is pretty similar. It's still in slope-intercept form. And let's do this. Let's create an x column and a y column. I'm still just going to choose the values -1, 0, and +1. Okay. And when I do this, all right, let's do this. I'm going to plug in -1 for x. So I've got y equals -3 times -1 and then +1. Okay, if I take -3 times -1, that's going to give me what is that, +3 and then +1, and so then y is equal to 4. So when I plug in -1, I get a y value of 4. All right, and that's all I'm doing, okay? And I put that number there. Now let's plug in 0 into this. So if I do y equals -3 times 0 plus 1, then you get y is equal to 0. -3 times 0 is just going to give me 0 plus 1. 0 plus 1 is just 1. Okay? So then I'm going to do 1 here. And then if I plug in 1 into this equation, I do y is equal to -3 times 1 and then plus 1. All right, and so I get y is equal to -3 times 1, which is going to give me -3 and then plus 1. So then I get y is equal to -2. Okay, and so I'm going to put that number here. Now, what I want you guys to see here is that this becomes the point -1, comma 4. This becomes the point 0, comma 1. This becomes the point 1, -2. Okay, and so at this point, you know what I want to do is plot those points. So I've got the point -1, 4. So -1, 4, 1, 2, 3, 4 is right here. Okay, I've got the point 0, 1, and then I've got the point 1, negative 2 is right here. Okay, now if I connect these with a line, okay, we've got a line like this. All right, let me move my screen up. And just like that. And what I want you to see is that you have all these other points on the graph. Okay? And so it's not something that we just graph these lines. Okay? Now what I also want you to understand here is that this point right here, okay, where it crosses the y-axis, this is my y-intercept. And remember that point is when x is equal to 0, okay? And so what I want to do is kind of look at these other equations down here to help me do that. All right, now this is a little bit different. Okay, you've got the equation 3y plus 5x is equal to 0. And what I know about this equation, this equation is in standard form. Okay, meaning that the x and y values are on the same side of the equal sign. So this is in standard form. Okay, what I want to do is turn this into slope-intercept form. Okay, so I want to transform into slope-intercept form. All right, and the way that I do that is I'm going to solve for y. Okay, and that's the idea. So doing this is a little bit tricky. Solving this equation for y means that I have to move everything else onto the other side of the equal sign, but keep y on this left side. So what I'm going to do first is I'm going to subtract 5x from both sides. Okay, and what I'm going to get from that is I get 3y is equal to negative 5x. Okay, and I'm just moving things. So, I can do that. We did that. We've been kind of doing this before. All right, so we had to, just make that jump that we're going to solve for the variable y, and we're going to get something in terms of x. Okay, now what I would want to do here is I'd want to divide both sides here by 3. Divide that side by 3 and divide that side by 3. My 3's are going to divide out, leaving me with y is equal to negative 5/3 x. Okay, now because we're dealing with a fraction, there's some numbers here that I'm going to be careful in how I choose them. Okay, and so I'm going to do this, x and y, create that column. Okay, now I'm going to choose a couple of points here. All right, now the one point I'm for sure going to choose is 0 because operating with 0 is really easy. Now you could put a negative 1 and a 1 here, but then we're going to be dealing with fractions, okay? And graphing fractions on a coordinate plane it's not that hard, but there are easier ways to do it. So because I have a denominator of 3 here, okay, what I'm going to do is I'm going to choose negative 3 for x and also 3. And here's why. Okay, when I plug those in, I'm going to get this. I'm going to get y equals negative 5/3 times negative 3 over 1. And when I do that, what's going to happen is that these are going to divide out, okay? And you could even just do this normally, just multiply across. We're going to get positive 15 out of this, divide it by 3, and that's going to give me a value of 5, okay? And so when I plug in negative 3, I get a value of 5. Okay, now if I plug in 0 here, y equals negative 5/3 times 0, that's just going to give me 0. All right, so that's good. Give me that point there. And then if I plug in 3, I get y is equal to negative 5/3 times 3 over 1. And when I multiply those together, I'm going to get negative 15 over 3, which is going to give me negative 5. Okay, and so what I end up getting here are these points. Okay, and this is going to turn into the point negative 3, 5. This is going to turn into the point 0, 0. This is going to turn into the point 3, comma, negative 5. Okay, now if I chose 3, okay, and let's think about this. Okay, I chose 3 for x because my denominator is 3. Okay, because of this denominator here. All right, so that's why I chose that number. Now, when I have these points here, when I have the point like negative 3, 5, okay, so I'm going to go to the left, 1, 2, 3, up 1, 2, 3, 4, 5, the point 0, 0, and then the point 3, negative 5, 1, 2, 3, 1, 2, 3, 4, 5, and I've got those points here. All right, and we can connect those. My line isn't very good, but we can connect those with a line, and that's what we have. Okay, now I'm going to do the exact same thing for this last one, and let's go ahead and do that. So I'm going to go ahead and subtract 3x from both sides, solve this for y. All right, and so I end up getting 4y is equal to negative 3x minus 8. Now I can't combine these as numbers. Okay, they're not like terms. This one contains an x, this one doesn't have an x, therefore I can't combine them. Okay, but what I want to do is this. I'm going to divide everything by 4, divide by 4, and divide by 4. All right, and so the 4's divide out, and I get this equation, y equals negative 3/4 x, and then minus 2, okay? And so I have this equation now. Now, because my denominator is 4, all right, when I choose my numbers, okay, I'm going to do x and then y, I'm going to choose negative 4, 0, and positive 4. All right, and so when I do that, let's do that over here. I'm going to do y is equal to negative 3/4 times 4. Okay, plug that in, and then minus 2. And that's going to give me, let's multiply across, it's going to give me negative 12 over 4 minus 2. And that's going to give me negative 3 minus 2, which gives me a value of negative 5. Okay, and so that's that value there. Okay, now the next one I want to do, we want to plug in 0. So I've got y equals negative 3/4 times 0, and then minus 2. So negative 3/4 times 0 is just 0. Okay, and that's going to be 0 minus 2. So then y is equal to negative 2. Okay, and so I'm going to plug that in. Maybe you're seeing a pattern here when I plug in 0, what we always get as my y value. But we'll talk about that later. Let's plug in 4. Okay, so I got y equals negative 3/4 times 4 over 1, and then minus 2. So then I'm going to get y is equal to negative 12 over 4 minus 2. Negative 12 divided by 4 is going to be negative 3. Okay, and then minus 2, and that's going to give me that y is equal to negative 5. Let me make sure I did all my math right. Oh gosh, this should have been negative 4. Sorry. So if I do this one, okay, negative 3 times negative 4 is positive 12. So I get positive 3 and then minus 2, which is actually going to give me a value of 1. All right, I felt like I had done this before. So this number here should be 1, and then this is negative 5. Okay, sorry about that. All right, so what we're going to do is we're going to get negative 4 comma 1. This is going to give me the point 0, negative 2, and this is going to give me the point 4, negative 5. Okay, so what I want to do now is go ahead and plot these points. And so I'm going to plot the point negative 4, 1, 2, 3, 4, 1. Okay, 0, negative 2, and then 4, negative 5. 1, 2, 3, 4, 5. Okay, and so all these points are connected by a line. But I want you to also see something. We also need to identify this y-intercept. Okay, and remember that the y-intercept is a thing when we plug in 0 for x. Okay, so there's kind of a lot of algebra going on there. This is kind of the long method when it comes to graphing equations, but it is fail-safe, meaning it will always work. Okay, so there will be other easier ways to do this and other easier points that we can plot. So I hope you enjoyed this video, and we'll see you soon. Thanks a lot. Bye.